If someone were to ask me, Jeremy, what is the cloud? And give it to me in the simplest possible way, one sentence, nothing more. What is the cloud as it relates to IT? I would say the cloud is taking all of your IT stuff, putting it in a car and driving it down to a data center. Voila, you're in the cloud. You no longer have your stuff on site. It's now hosted offsite. I know it's not glamorous to say it that way, but that's the simplest possible definition I could give you. And that's what a lot of people think about when they think about going to the cloud, is putting your stuff in the trunk, driving it down to a data center. That's the traditional method of doing this. And there are some very unique advantages that you get when you build your own cloud, when you take it to the data center. So I want to look at the traditional method of building a cloud, and then I want to look at the way that AWS does it, Amazon Web Service. What does it look like to go to the cloud with Amazon Web Services? Then I want to contrast the two. And I know this is a series, it's all about Amazon Web Service. So of course you're expecting me to be like, well, come on, why would you not use Amazon Web Services? And maybe I will say that. I don't know if I haven't gotten there yet. But what I will say is I really want to give an honest side-by-side comparison. Let's just look at it. Let's look at the traditional way, and let's look at it AWS, and let's just see where the chips fall, right? Finally, I want to wrap up this nugget by looking at a concept you'll hear again and again and again as you hear about Amazon Web Service, and that's horizontal versus vertical scaling. I just want to peel back the mystery beyond that and explain what that means. Well, let's kick it off by taking a look at building a cloud presence yourself, the traditional model. If you want to go to the cloud, first thing that you need to do is pick a data center. Now, there are thousands of data centers all around the world in different shapes and sizes, different advantages and disadvantages. I happen to live in Arizona, which is one of the most populated areas for data centers because we don't have natural disasters outside of a tumbleweed blowing by and it's really hot. But otherwise, it's a wonderful place to live because you're not going to get flooded or earthquake or anything like that. And so people saw that and built a bunch of data centers. This one on the screen is IO Data in Phoenix. Happens to be a data center that I have equipment in. Advantages of it, it's amazing. It's one of those impress your friends. I mean, some people go to the movies. I'm like, hey guys, come with me to the data center. Check this out. It's one of those retinal scans, man traps. Raised floor, thermal cabinets where everything's enclosed and every cabinet is air conditioned. It's just one of those wow when you walk in. But I wasn't always there. I didn't always have my equipment there. I'm not even going to mention the name of the old data center, but it was really cheap. I paid what was it, $130 for a quarter cabinet of space. And I walked in and there were Carnival fans. That was their cooling. Was Carnival fans, really big fans blowing on everything. It was scary, but that's where I got started with a lot of what I was doing. So again, data centers, different shapes, different sizes. You pick one where you want to put your stuff. You pay them a good amount of money. So you're going to purchase some rack space. So what I mean by that is inside of that data center, you're going to have a rack of equipment. Now sometimes it's just going to be two posts, and you're going to mount all of your servers and switches and routers and all of your stuff on these two posts. Other data centers have thermal cabinets, which are enclosed. Completely enclosed. They have air condition connected to the top of this where it sucks all the hot air out the back and blows in the cool air from the bottom, the raised floor in the front. So again, different shapes and sizes. You pick your rack, and based on that rack, you're going to pay a monthly charge just for the rack. And I'm bringing some of this stuff up because I really want to get in your mind one of the big differences you're going to see in a little bit is cost. You're going to be paying for the rack to put your stuff, how much of the rack you want or how many racks you want, what kind of racks you want. Okay, from there you purchase your internet connectivity. Meaning, just having a rack in a data center is great. I mean, you can put your equipment all in there all day, but until you get out of the data center, it's no good. The way that a data center is structured is inside of it, you have all of the customer, let me draw it kind of like this. This is actually how IO Data is structured, where they have all of the customer racks and cabinets. I mean, just thousands and thousands of square footage of just customer racks that are all this kind of thing. Now, over here is what they call the meet me room. And that meet me room is where all of the carriers come in. And I mean, carriers, I'm talking about internet service providers. You've got Sprint, Quest, well, they're called CenturyLink now, Cox. You've got XO Communications. You've got blah, 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 blah. All of the different carriers come into that data center. And now you have an agreement that you need to make from one of those carriers. Let's say I choose Cox. And I say, okay, I'm going to use Cox as my service provider. I'm going to now pay Cox a monthly charge for them to run a fiber optic cable to my cabinet, and now I can use those. Now, a lot of data centers will offer their own, like for instance, I'll talk about IO data. They offer their own blended solutions, meaning IO data themselves have their own devices, and they take a whole bunch of these carriers and bring them in, and then sell you what's called a blended internet circuit, which means it's no longer tied to any one carrier. It's blended across a bunch of them, and that's great, because now you're not, if Cox goes down, you're not stuck because IO says, oh, well, we'll use XO or CenturyLink or whomever as a backup for you. Now you're going to pay. Again, I'm back to the thought behind the pricing model. You're going to pay for how many carriers you want. You could build your own blend. For example, I could bring in CenturyLink and Cox and XO into my rack individually and kind of blend them together. That's fine. You can pay IO data to do that for you. You're going to pay for how many carriers you want and for the speed of the connection. So if I would say I want 10 megabits per second of bandwidth from CenturyLink. Okay, bam. There's a monthly charge. I want 10 megabits per second from Cox. Bam, another monthly charge that I'm getting. Now keep in mind, I'm thinking ahead of AWS and where we're going to go with this. It's not like because I have CenturyLink I get a discount on Cox. These are competitors. These are different carriers. So just keep that in mind. Okay. Next, now you've got your rack, you've got your internet connection. Now you install your equipment. So what's that look like? Well, kind of like this right here. You've got the rack. You go, and this is exciting. It's frightening to put your credit card on the line, but you go on whatever website you want and go buy a bunch of really nice gigabit, 10 gigabit, whatever switches. You go buy some firewalls to put in there. You buy the cabling for. I mean, this is your world. You're building a house. You're going buying the cables. You're buying the power supplies. If you want UPS backups, usually the data center provides their own power backup and they guarantee power to a certain level. But some people say, well, I want to go above and beyond. I want to do UPS backups, and at least I need to have remote power to where I can power cycle something remotely. I don't want to have to drive to the data center if a server freezes and I can't reboot it. So you'd at least want to buy some power units allowing you to remotely power on and off different devices. You buy your servers, of course. It's huge. All the different servers that you're going to install. That's the lifeblood of your rack right there. That's the services that you're providing. Some people even go further and go for the storage. They install what's called a SAN. Or a NAS, same concept. SAN is a storage area network, really fast, pricey storage. NAS is network attached storage. It's I'll say cheap storage, a lot of it, but usually not as redundant or as fast and performance-wise as a SAN would be. So again, we're building our own world here. Then, now you configure your services. Okay. So stop right there. Up till now, we've been building the house. When we get to configure the services, now you're saying, here's what I want to do in my cloud. I want to run a website for the world to see. I want to run an FTP server to serve files. I mean, this is who are you? What's your whole point of going to the cloud in the first place? I want to run a terminal server, a remote desktop server, so people can remote desktop in and get a different environment and run applications. I want to run Citrix. I mean, this is what IT service are you planning to provide from the cloud? Maybe you're just moving your business to the cloud and you're like, okay, what does that mean? Well, typically that would mean you're going to put thin clients at your office location and access their access their desktop, that access their storage, everything from the cloud. And you're going to use something like it's just on my head, so I'll say Citrix or Microsoft Remote Desktop style connectivity to offer those kind of services. So this is the what are you doing there? And then the final step is to expand to more data centers. Meaning, uh, right now I just gave you an example of I am using IO data in Phoenix, but there's a couple kind of, let's think this through. Number one, IO data center in Phoenix is phenomenal. They're one of the few that has 100% uptime SLA. That's amazing. So 100% uptime. So that's great. So IO Data, the CEO there is telling me they are up 100% of the time, and man, I hope he's right. So far he has been. I've been in IO Data for 2 years now, and so far he has been. But man, if something went bad at IO Data, their air conditioner went out. In Arizona, it's 120 degrees in the summer. Boom, that data center is 180. All my servers are shutting down. Everything's frying inside of that data center. That would be a problem. For me, so while I feel good, I signed the agreement with them. They said that it's 100% uptime SLA. As my company grows, I'm going to want a little more assurance. Sure, IO Data is great and they're guaranteeing me that, but that's one company's guarantee. Let's go with another data center. Let's move over to CoreLink data services, and let's add a redundant site there, because while they're guaranteeing me they're up, a guarantee is only as good as that data center that provides it. So if something goes wrong at the data center, I want a backup. So we move to CoreLink and add a backup. So that's the number one reason that we go to multiple data centers, is I want redundancy. I don't want all my eggs in one basket. Second reason I go to multiple data centers is for speed of access. I am at this data center in Arizona. It's probably not going to perform as well from China. If I wanted to run maybe hosted voice over IP services, I want to support phone systems in China. Well, you know what? It's a long way from Arizona to China. There's an ocean between us. And so what I might do is, as I grow and I really see a market in China to provide voice over IP services, I might go to a data center in China and build my own world there, so that I can service the customers in China without having the long delay in their traffic, which is really bad for voice over IP. You get really choppy voice and things like that, lagged audio. I don't want that long delay, so I would go to another region of the world to do this. Now, oh man, I feel like, I've got to say, as I'm talking about this, I feel like I'm setting somebody up. Like if you know Amazon Web Services, if I were hearing me speak, I would be like, oh, okay, this is a setup to come in and say this is how glorious Amazon Web Services are. I'm really not doing that, because I built a traditional model. I'm in IO Data Phoenix, and I love it. It works well. But I want to now talk about this as it's compared to AWS. So how do I do that same thing with Amazon AWS? Well, okay, first off, I've got to get it out there on the table. Saying Amazon AWS is redundant because AWS stands for Amazon Web Services. So I'm really saying Amazon Web Services, but that's okay. Everybody does that. So how do I do the same thing? First thing, there's no truck involved. I'm not driving my equipment anywhere. Oh, stop right there. There's no equipment involved. I'm not going on the web. I'm not buying switches and routers and cabling and servers and all the stuff that we did traditionally. I'm going on the website. And I'm first off going to pick my region. Now, the regions are literally areas of the world. For instance, I can see I've got over here US East 1. I've got, looks like Europe West 1. Just looking at the names, I'm assuming that's where those are located. And these are regions of the world where Amazon owns data centers. Now, I, Jeremy Chara, am in Phoenix, Arizona, so I'm not going to go to Europe because maybe I want it to be close. I want to have really good performance, really fast response times from the closest possible data center. So I would go, for instance, I'm just going to take you right here, Amazon Management Console, and right here, right there, there's the region. By default, I'm in US East. So in the US East region, which is in Virginia, I can see that there are 3 different availability zones, and they are all operating normally. Thank you, Amazon, because they should be. Those availability zones, those are the little white clouds that you see inside of there. Those are literally data centers. They're all independent, kind of separate data centers that are isolated from each other. Well, I say isolated, but meaning they operate independent of each other within that region. So East, that's not my side of the world. That's the other side of the United States. I'm going to go West Coast, and it looks like Amazon has two different ones. One in Oregon, which is great for CBT Nuggets because that's where they are. But I'm closer to California. I'm choosing California, and you'll see it kind of loads and refreshes and goes, okay, well, California is operating normally, and it looks like there are two availability zones there. There are, and let me translate that. There are two independent data centers there. Okay, so I'm sitting there thinking, okay, well, I don't really care. It's not like one is better than the other, and wow, that one is a good facility, and that one's. I mean, they're all kind of created equal in this. So I'm going to pick my region where they're going to be. I'm going to pick my availability zone, and I'm going to provision my server. Again, not buying anything. I'm going into the Amazon management console here and launching an instance, and it says, okay, well, what kind of server you want? And I'm getting into some of the future nuggets I'm going to do on provisioning servers. And I want to run Windows Server 2000 R2 base architecture, or just base installation, just vanilla kind of 2008. So I say, okay, availability zone. Let's choose that data center. US West 1A. These are just identifiers of the data center in California. So I'm going to say, let's go that one. Now, before I go any further, I need to also say, well, how big do I want that server? Now I truly am getting into some of the cross-pollination of that. So this is where I would say, well, I want a really big server. I want an extra large. It's like McDonald's or something like that. I want an extra large server that I can go. So I provision my server. I go through. I choose the operating system. I choose how big I want it, and then I configure my services. That's it. Meaning I'm in the cloud. I'm ready to go within a few minutes of clicking next, finished. Oh, okay. I don't want to dive into let's compare yet, because I'm going to do that. I have a whole slide dedicated to just comparing. I'm just talking about here's how we do it with Amazon. So now I want to emphasize, I'm going in, I'm setting up my remote desktop server, or I'm setting up my website, or my FTP server, or my maybe I want to host my own music streaming service, or whatever you want to. I mean, this is you. What do you want to do? What does your company provide? Maybe it's just to support my internal employees with a database of customers that we use to track. So again, what are you doing? So then, now again, going back to traditional. In the traditional, once we established our services, then as the needs arose, we would start moving to other data centers. Again, buying equipment, moving into other data centers. Here, I would expand to other availability zones. So I would say, okay, well, that's great. Let me get my web browser back up here. That's great. I've launched my server in US West 1A, but I want a little redundancy. I want multiple data centers involved here. So I'm going to launch some additional servers, some redundant servers in US West 1C. Now, we haven't moved beyond the region. We're still in the same area of the world, but now we're in totally independent facilities. So I've got one facility that maybe I started in, and now I've got another facility of servers that I've expanded in. So again, click. I choose the availability zone, and I'm back in my traditional model. There we go. And bam, I'm in multiple availability zones. So now I've got multi-data center redundancy with a couple clicks of a mouse button. I want to expand to other regions, meaning, okay, now our company has grown. We want to provide those voice services to China. Let's go pick a region closer to China so they don't have to travel over the ocean through satellite connections or whatever else to reach my servers and my data centers. Okay. I can't hold back. I've got to now compare the two. So what I tried to do was put these two solutions side by side and do as neutral of a comparison as possible. And the reason I say as possible is because once you've seen Amazon Web Services and you know it, you're kind of like, wow, that's really good, so you come in with some bias, but keep in mind you're also hearing from a guy that has the traditional model. I have servers in a data center. I like it. I love having my servers that I can touch in the data center, but let's compare them. Traditional model. Number one, you have a massive upfront cost, and you have what I would call as big steps. So you're buying routers, switches, firewalls, servers, storage, all of that, a huge initial investment into your infrastructure just to get going. And then you have to take what's called big steps. This is straight from Amazon's website, which I thought, wow, what a great visual picture, this is where you get started. Your we'll say $40,000 of initial equipment that you're putting in there. Your customers come in, and keep in mind, customers. I'm using that term loosely. That could be your employees. It could be your clients on the web. We're talking service neutral right now. So whoever you're supporting comes in, like, this is pretty good, great. But they tell their friends, you get more of them, or hire more employees, or do more, and they start exceeding your initial investment. So you have this little gap here where the red, that's the customer, exceeds your capacity at the data center, and things start running slow or not responding, and you have outages and things like that. So the red line represents this customer dissatisfaction. They go, oh, hey, this isn't working. Hey, complain. And then you go, okay, well, let's drop another $70,000, get some upgraded servers and storage, and that way we can provide for them. And they go, woohoo! You just blew their expectations away. Probably setting more expectations by doing that. But it's all great, it's all fast. Wow, thanks guys, that's amazing. And you go, yeah, great. Go tell your friends, and they tell their friends. And so as the more customers come, you start, you're getting better to where they're not exceeding. But you reach another point where you go, okay, now we got to add $100,000. You see what I'm talking about? So you're buying all of this gear because you can't, right here's a little economic downturn. Your customers went down, but then really spiked back up and way over exceeded what you're doing. It's really hard to plan for capacity in a traditional data center without having a lot of investment going to where you are either always overachieving. You're providing way too much because you're saying, well, just in case those customers get out of control, and then you can see right there they're exceeding it. So you get the point. That's the big steps, because you have to buy these massive investments. There's no smooth way of scaling it. IT staff, you've got to hire people that are focused on the data center, and they're not cheap. Data center people, the people that handle routers and switches and VLANs and site-to-site VPNs and installing servers and virtualization and vSphere and blah, 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 blah. The traditional way of doing things, they're expensive people, and those people are focused on supporting the data center. They're not providing new services. At least not for the most part. They're just focused on making sure that server is up to date on its maintenance, making sure it's patched, making sure that you're achieving your security compliance and all of that. You're also hitting your IT in-house knowledge limits, meaning in doing it all yourself, you're going to be limited by the people that you have on staff. You might hire a consultant maybe to come in and give you some new ideas, but there's no services that you're getting. And I'm doing this in such a way of, I know what I'm going to talk about over here, but there's no services that you're getting with your in-house people. They're just there to maintain the system and come up with their own ideas. So they're a knowledge limit. You're recreating the wheel, meaning you're building an infrastructure that you are buying a rack of equipment, you are installing your own switches, your own firewalls, you're doing it all yourself. So you're kind of treading the same ground gone before you. A lot of times when I think about Amazon Web Services, I think about shipping a box. You can either get in your car and drive that box to the destination you want to ship it to yourself, which is great, or you can go and pay somebody $20 or $30 that has already invested in the infrastructure to ship the box for you. They've got the trucks, they've got the staff and personnel to go take that box where it needs to go. So a lot of times it's like, well, how about we just let them ship it? But I'm still talking about traditional. So let me not talk about Amazon Web Service. Let me talk about it from my own perspective. I have equipment. Number one, it's yours. That just gives you a warm fuzzy feeling. To have your own infrastructure is great. I can drive out to IO Data Center and walk in there with my little retinal scan, and it's a cool feeling, and touch it. Now I want to bend the paradigm a little, because I pulled back. Initially when I wrote this, I had quotes around "it's yours," just like you can see right there. Because I thought about it, I'm like, well, it's mine, at least up to my rack of equipment, but I'm still assuming that IO Data Center, the CEO of IO Data Center said, I have an 100% uptime SLA, service level of agreement. So I'm taking him at his word that I'm going to get 100% uptime, but I sure hope that's right. And I'm hoping they keep that center secure, and I'm hoping their internet connectivity stays up with the carriers that I've chosen. And so when I'm saying it's yours, I'm saying, yeah, there's a piece of it. I bought my servers, I bought my storage, but I'm relying on other people a lot. to get that to where it needs to be, to make it part of the cloud. Meaning, it's not really mine if I think about it, other than my own equipment that I've put in there. I'm relying on a lot of other people to make sure that it works correctly. Other benefit that I get with the traditional model is monster servers. Tim Allen walks out there, right? So you can go out and you can buy the beefiest, drop $100,000 on a server with 96 cores and terabytes of memory. That is, I mean, you can create the biggest, beefiest machines in the world that you want. And so let me take that as my opportunity to jump over to the Amazon Web Service side. Amazon Web Services has very large servers that you can provision. Matter of fact, they've even called them things like that, like extra supersized large. You'll see some of the models, but they don't allow the monster servers. I mean, I'm talking giganto. So again, I'm jumping ahead of myself. Number one, Amazon Web Services is pay as you go. You don't have to drop the $40,000 to get into the data center. You can go to Amazon. Matter of fact, you can sign up for an account and get one free for a year. I think you can run a server in a data center that's limited in its capacity because it's free, but you can then start transitioning that. You can say, okay, let's start free and let's transition to a small server and maybe pay a few cents an hour to keep that small server running. And then you start saying, okay, well, it looks like we're doing well, a good design. Okay, let me add a second server. Let's increase the capacity of those servers. So you can slowly increase it as you go. And here's their model, to where you kind of slowly build up over time as you see your customers coming in. Now you can see no customer satisfaction. Now I know if you're like me, you're skeptical about everything. You're looking at a little graph going, oh, okay, yeah, but come on. Anybody can draw a smooth line and say, see, there's no customer dissatisfaction. But how is that possible? Well, what you can do is you can grow as needed automatically. Meaning, you can set up boundaries with Amazon Web Services that say, okay, when we start to reach capacity, automatically add another server. Amazon, go ahead and power up another server and replicate this model. I'm going to add a little workhorse to handle that. And then, maybe you could even get this granular. You can get this granular. I can say, when my customer load reaches its peak, which is typically at 1 p.m. to 4 p.m., add 3 servers. Blow their expectations away. We're handling it. And then you know what? When 4 p.m. hits, I want you to shut down 1 server per hour, 5 p.m., 6 p.m., 7 p.m., until we're back to our normal quota. So again, you're paying for what you use, and you have multiple pricing models. I'm going to have a whole nugget just on pricing models, but you can use on-demand, which is simple. You can buy down by committing to the service. I mean, there's all kinds of different ways to approach it. This is all considered as Amazon's term. They call it EC2. It stands for elastic computing. Elastic computing means you add more as you need and then take them away as you don't need. It stretches to meet the need. Now, there's a big design change that has to go on in your head. If you're a traditional guy like me, my design is like, okay, I buy a big server. That's what I do. But you really have to think about it in terms of stretching instead of just adding these giant capacities like you do over here. Economy of scale. They are the shipping company, right? Amazon has built this massive infrastructure, and that's really how Amazon came to the model. They have a massive infrastructure because they're within the top 10 websites of the world. They're huge. So they said, well, why don't we just start selling our infrastructure that we've already invested in? Why would you go build it yourself when we've already built it for you? So you also get, this is something I didn't even mention on the other side, immediate security accreditation. Amazon has gone through the work to get things like PCI compliance, like HIPAA compliance, like ISO. I mean, there's all kinds of security standards that if you do it yourself, you have to come in and have an auditor say, okay, you check all these check boxes, government standards, blah, blah, blah. Okay, you are compliant. And then you have to keep up with that compliance. Amazon does that for you. So again, let's make that a reality. You're talking to a customer who's an accounting firm wanting to use your services, and they say, are you PCI compliant? If you're with AWS, you go, yep, we are. I mean, it's not even a thought. If you do it yourself, you're like, oh, yeah, we are, because you had to invest in that. You had to pay for that. Multiple data centers easily. Oh, such a huge benefit here. I am in IO data centers out in Phoenix. It would cost me a fortune to go and create a second or a third or a fourth data center presence. They call them POPs, point of presence. That because I have to invest in the same infrastructure. With Amazon, I just check, go to you just saw it on the previous slide. Go to a different availability zone. Go to a different region. You can spread across with the click of a button. Collaborative innovation. I came up with that myself. I was rather proud to use those two words together. This kind of goes right side by side with the in-house knowledge limits. When you get going with Amazon Web Services, it's like Christmas every month because they send out their newsletter and they're like, oh, by the way, we've added this. I mean, just innovative solutions. We've added Route 53 for DNS. Oh, we just added the ability to load balance over connections that are using our VPN services. I mean, there's all kinds of different innovations that they're coming up with. There's buildings full of people that are working to innovate the cloud presence, and you gain the benefits of that rather than hitting the wall of your own IT people, which I'm not saying that's a wall. You may have great IT people. This sounds bad. I'm a great IT person, right? I'm a good IT person. I think of cool things, but I can't compete with a staff of 100 people that are all thinking of cool things at the same time. And they have the resources to move forward with those cool things. That's what AWS is doing. And I mean, I could keep going on that. So that's collaborative innovation. Last piece is something that I call horizontal scaling. I thought I would create its own slide for horizontal versus vertical scaling. When you deal with AWS, you'll hear people talk about this quite a bit. Vertical scaling is, I would say, more of a traditional model, which is considered scaling up. That's where I say, okay, I need more capacity, so I am going to buy more servers with bigger processors, more memory, all that kind of things. I mean, the beauty of vertical scaling is it's easy to do. You say, okay, I need, maybe my server has 4 gigs of RAM. It's maxing out. I need to add the chips to go up to 8 gigs. Or 16 gigs, or whatever size you want to. That's what we typically think of as scaling. With Amazon Web Services, this term has come out, which initially it takes a sec to kind of change the paradigm to, called horizontal scaling or scaling out. So instead of adding more hardware and throwing hardware at the issue, you increase instances. So when you deal with Amazon Web Services, everything is virtualized. So behind the scenes, let's look at Amazon's data center, right? One of them. In the data center, they're just going to have racks and racks and racks and racks and racks. All these different racks of just packed full of servers. And so what you get, and these are all servers that are in the racks, what you get is the ability to generate servers from those. So I say, okay, I want to create a Amazon Web Services server. You go through the window, next, finish, and poof, you have this virtual server, which is supported by any number of actual servers behind the scenes. I mean, there's servers that are handling the storage for that. There's servers that are handling the processors for that. All that kind of stuff. So you have an AMI, or an instance that is generated that you see. That's the result of it. So what you can do to scale is instead of just making that AMI bigger, which you can do, you can add hardware, virtual hardware. You can add more processors, more memory. That's the vertical scaling. What the new model is let's make it wider, scaling out. Let's create more instances that can run on a whim. You can boot them up on a whim and have them working, and then you can shut them down. Now, those instances could be generated from an image behind the scenes that you create. So let me give you an example. Let's say you run a website that is very popular. It's starting to sell laser pointers. Let's just make it up. You came up with a $5 laser pointer that can shoot a laser to the moon. It's so powerful and burn through small pieces of. Now I'm getting into my own fantasies of a cool laser pointer. So it can burn through paper. So you create this website for laser pointers, and all of a sudden you notice that huge. It becomes huge in the United States. So 8 to 5, people are really hammering your websites, ordering laser pointers, configuring custom setups for your laser pointer. I'm trying to make this website more than just buying a laser pointer. So you could have a web server that is the front end. Maybe you started with one and you saw the business happening. You can have it generate a new web server from your same image. The same image that was used to create this web server could generate another one and another one and another one. You start creating these little clone web servers that are all pulling from the same database, the database server behind the scenes where it's storing all of the order information, it's storing all of the facts about your laser pointers and the different models that you sell and all that kind of stuff. So these web servers, instead of being like, the traditional model where that web server has its files on there and all that kind of stuff. Instead, it's just a workhorse that you can bring up these. I'll draw a little horse here. Kind of. You've got these little workhorses. That's really bad. That you can pull up at any point and say, okay, service more laser pointer requests. Boot it up, boom, boom, boom. You just bring them up on the whim, and you can even set thresholds to do that. They're all using shared capacity, meaning they're all pulling from that same database. This typically requires planning. So you can bring these servers up and you can bring them down as the load increases on your website so that they're able to service demands. Amazon Web Services, I'm getting a little ahead of myself, but includes a load balancer where I can say I want a load balance between all of those web servers. And as more get created, and my little mutant horse here, more get created, I can load balance to that guy and add him to the loop to really distribute that load. That's the feeling. I really want to convey that feeling of what horizontal scaling looks like. Now, you notice I have all of these coming down to this diagonal scaling, meaning it's usually you're going to be a mix of each of these. You might notice that, hey, these web servers even individually can't keep up with the requests, normal requests from clients. At that point, I would say, okay, let's increase that from maybe it's at a small instance. You gauge your different levels. Let's increase that to a large instance. That's vertical scaling. But then let's add 5 more web servers. That's horizontal scalings that are also large instances. And now you've got a complete solution. Isn't that so good? I mean, just to start getting the scope of what Amazon Web Services is about. And again, through this whole series, it's just going to be paradigm change after paradigm change. You'll really start to see many uses of this. And I think that's going to be the glory of this series, is really opening your eyes like, wow. This is good. I remember when I signed up for Amazon Web Services originally, years ago. So someone sent me an email or something, and it was like, hey, check this out. And so I went there, signed up for the free account, started a virtual machine, and I was like, that's pretty cool. Neat. Shut it down. Didn't think a thing of it. I don't even know what happened to the account. It expired or whatever. Just because I didn't really think of the possibilities. I didn't think of the uses of Amazon Web Services and what it's really capable of. So as we go through this series, that's my hope, is that, sure, let me convey the technical aspects of this. That's going to be a massive part of what we're talking about. How do you do it? But I also just want to keep giving you groundbreaking moment after groundbreaking moment. It's like, wow, I really see how this could be useful to us. Good. All right. Well, what we've seen in this nugget is really the traditional and Amazon Web Services, what those two look like, comparing them side by side, and then that big concept of horizontal, which is more instances, versus vertical, which is more memory and processor scaling. I hope this has been informative for you, and I'd like to thank you for viewing.